Dear colleagues and participants of the conference, my name is Viktor Zhukovskyy and I would like to present the results of our scientific research regarding the regression analysis of grain production transformation in western, central and steppe regions of Ukraine. All we know, the climate change is affected by the agro-production by the most. The decline in crop yields is causing global food security problems. Furthermore, the variety of biotic and abiotic factors affect the crop yield, including temperature stress and water scarcity. Therefore, scientists have a task to anticipate changes in climate factors for the coming decades and to develop a strategy for adapting humanity to these changes. And at this time, the following trends are observed on the world grain market: constantly growing demand for grain, stabilization of gross production, decrease in sown areas and increase in crop yields. According to statistics, world grain production is increasing, but the grain supply in different countries differs markedly. In many countries of the world, grain supply is insufficient due to the climate, soil, or insufficient technology development, and they are forced to import grain. Ukraine has been ranked among the top 4 in terms of grain supply, due to favorable natural and climatic conditions and technological development in recent years. Gross grain production is sufficient to support both domestic and export needs. Wheat, corn, and barley are the basis of Ukraine grain export. As we can see from the figure 2, almost 50% of the export structure is corn. The second place taken by the wheat, about 40%, and the share of barley is about 10%. Current trends in world population create some food security stresses. Therefore, taking into account the growing needs of the world's grain market, Ukraine has a reason to increase production and export capacity. The forecast of gross grain production and grain export from Ukraine are obtained by the method of linear trend extrapolation. As we can see from the figure 2, the dynamics of grain export from Ukraine have a positive trend, and the analysis shows that the export potential can reach 50 million tons in 2023. That's why there is an urgent task occur to predict the grain production and analyze the grain production factors in Ukraine. And we can use the regression analysis tool. This is a powerful statistical method that allows us to examine the relationship between 2 or more variables of interests. To do this, we split out Ukraine into several regions: to the western, central and steppe regions of Ukraine, and the study was conducted taking into account these classifications. As a result, we have developed several predictive models: linear trend model, where T is the estimated value of yield, T is the time, A and B is the trend model coefficients. After regressive model, where Yt is the current grain yield, Yt minus 1 yield in a previous year, Yt minus 2 yield 2 years before, Yt minus 3 years ago, and so on. And multiple linear regression model, where Y is the crop capacity, x1, x2, xn the climatic factors affecting yield, U is the random component. And our task was to find out the necessary coefficients for these models. So, all these trend models are useful for estimated yield growth over several years. Since it is important to estimate trend and less important to take into account yield fluctuations. Cyclicity was inherent in both natural and economic processes. Science yield is the result of the activity of the natural economic system. It is also inherent to this property. To identify the cyclic component of the time series, we use the autocorrelation function and spectral decomposition using the Fourier transformation. And we find out that variables that correspond to statistically significant autocorrelation function coefficients are included in the model number 4. That research has shown that the first, second, and fourth coefficients are mostly statistically significant. Therefore, in the future, we will use them. And at the same time, we find out that in same regions, coefficients R4 is not important, so we can skip it. As a result, after the numerical experiments which took into account the data from the official datasets available on the website of Ministry of Agrarian Policy and Food of Ukraine, that coefficients are presented on the table 1 for different clusters, different regions, and table 2. And as we can see from the figure 5, the model is not able to predict crop failure caused by bad weather conditions. Since 2011, there is a mismatch between the size of the forecast and actual graphs. Research have shown that this is a consequence of significant climate change and the use of new agricultural technologies in Ukraine. All this has led to a marked increase in cereal yields in recent years. Therefore, the cyclic component of the productivity series is noticeably weakened. During our study, we presented trend model, autoregressive model, and multiple linear regression model for assessing yield growth in western, central, and steppe regions of Ukraine. We confirmed the adequacy of models according to the Fisher's criterion, which allows us to use them for forecasting. The good adequacy of the forecast models of autoregressive type is received due to the effect of cyclic production. Studies have shown that autoregressive models are not suitable for predicting cereal yields in the western regions of Ukraine. Therefore, to predict the yield of grain in this region, it is necessary to apply other forecasting models. Grain production is a highly risky industry due to the significant dependence of productivity on weather and climatic factors. Over the past 70 years, grain yields in Ukraine have increased by 60%. At the same time, grain yields in the developed European countries are twice as high. This means that Ukrainian grain producers have significant unrealized reserves of yield increase. We are planning to use those autoregressive multi-regressive analysis mechanisms into our information analytical system of organic agriculture. The main idea of this system is to help to find the best size for landing use and start the organic business. Also, we would like to say thank you to Alberto Tonta for his support and to say thank you for Cost Action, which help us to publish this scientific research. Thank you for your attention, and we are waiting for your questions, comments, suggestions, and ideas for possible future cooperation. Thank you.